November 18, 1943, 2:14 a.m. Makin Atoll, Gilbert Islands. The darkness smells of salt and aviation fuel. Technical Sergeant William Bill McKenzie crouches beside a disabled P-40 Warhawk on a coral airstrip, so new that construction equipment still litters its edges. His hands are black with grease, knuckles bleeding from where metal bit flesh in the humid night. Around him, the Pacific stretches infinite and invisible, marked only by the sound of waves breaking against the reef. The airfield, if it can be called that, consists of a single runway carved from crushed coral, 8 fighter aircraft, and a collection of tents that house fewer than 200 men. There are no hangars, no proper machine shops, no electrical grid. When the sun sets, the base goes dark, except for handheld flashlights and the occasional flare. And yet, by dawn, 12 more fighters are scheduled to arrive from Hawaii, requiring fuel, requiring maintenance, requiring ground power to start their engines in an environment where conventional power sources do not exist. Mackenzie's problem is elementary and catastrophic. The portable ground power units, heavy diesel generators designed to provide the electrical current needed to start fighter aircraft, are not working. 3 of the 4 units have failed in the 4 days since the Marines seized this island from the Japanese. The 4th is running barely, but cannot sustain the voltage needed to turn over the Pratt & Whitney engines in the P-40 set. Without ground power, the fighters cannot start. Without fighters, the airfield serves no purpose. And without this airfield, American forces pushing westward through the Central Pacific will lack air cover for the next series of amphibious assaults. The entire operational tempo of the island-hopping campaign depends on this coral strip and its 8 inoperable aircraft. Mackenzie stands, wipes his hands on a rag that merely redistributes the grease, and walks to where a Willys MB Jeep sits parked near the fuel dump. The Jeep's engine is running. It has been running almost continuously for 3 days, used to haul supplies, tow equipment, evacuate wounded. Its 4-cylinder engine produces 60 horsepower, enough to move a quarter-ton vehicle across terrible terrain, enough to power a generator if properly adapted, enough, Mackenzie is beginning to believe, to solve a problem that military logistics has declared unsolvable. The Pacific War was in 1943, a war of distances and logistics more than tactics or heroism. The vastness of the ocean theater created challenges that European planners could scarcely comprehend. Islands captured from the Japanese had to be transformed into functional airbases within days, sometimes hours, to support the next leap forward. But building a conventional airbase required months of construction, concrete runways, fuel storage, maintenance facilities, electrical infrastructure, communications equipment. The Americans did not have months, they had weeks at best, often less. The solution was improvisation on an industrial scale: use what you have, make it work, move forward. Seabees, the Navy's construction battalions, became legendary for their ability to carve airstrips from jungle and coral with astonishing speed. Using bulldozers, graders, and crushed coral mixed with sand, they could create a functional runway in 72 hours. But a runway without aircraft was merely a long stretch of flat ground, and aircraft without maintenance, without fuel, without the electrical power to start their engines were expensive sculptures. The logistics tail required to support a forward airbase was immense. Fuel had to be shipped in drums and pumped by hand, spare parts had to be scavenged from damaged aircraft, and electrical power had to be generated by portable units that were themselves temperamental machines requiring fuel, maintenance, and expertise. The portable ground power units used by the Army Air Forces in the Pacific were essentially diesel generators on wheels, designed to produce the high amperage direct current needed to engage an aircraft engine's starter motor. They were heavy, mechanically complex, and critically prone to failure in the harsh conditions of tropical islands. Salt air corroded electrical connections, coral dust infiltrated fuel lines, heat-stressed components designed for temperate climates. And when they failed, as they frequently did, the technical expertise required to repair them often did not exist at forward bases. Aviation mechanics understood aircraft engines. Ground crews understood how to fuel and arm planes. but the specialized knowledge needed to troubleshoot and repair diesel generators was in short supply, concentrated among rear echelon units that could not be spared for every coral atoll captured from the Japanese. William McKenzie was 31 years old, a career mechanic from a small town in Oklahoma, where he had operated an automotive repair shop before the war. He possessed no engineering degree, no formal military training beyond basic mechanics courses. What he possessed was a lifetime of experience, making broken things work with inadequate parts and improvised tools. In rural Oklahoma during the Depression, you did not replace a failed component, you rebuilt it, adapted something else, or fabricated a solution from scrap. This mindset, pragmatic, resourceful, contemptuous of the idea that problems were insoluble, made McKenzie invaluable in the Pacific, where supply lines stretched thousands of miles and replacement parts might take weeks to arrive, if they arrived at all. McKenzie had landed on Macon Atoll with the first echelon of aviation support personnel, arriving hours after Marines secured the airfield in brutal fighting that left Japanese defenders dead in their bunkers and American casualties scattered across the coral. His orders were simple: make the airfield operational, support 12 fighters initially, with capacity to expand to 30 within 2 weeks. The reality he encountered was more complex. The Japanese had sabotaged what little infrastructure existed before withdrawing. The coral runway was pocked with shell craters, fuel drums salvaged from Japanese stores were contaminated with seawater, and the ground power units, shipped from Hawaii and offloaded directly onto the beach, had been soaked in salt water during the landing and were corroding internally even as mechanics tried desperately to make them function. For 3 days, McKenzie and a small team worked to repair the diesel generators. They cleaned fuel injectors, replaced corroded wiring, rebuilt starter motors with parts cannibalized from one unit to repair another. They achieved marginal success. One generator would run for an hour before overheating, another produced insufficient voltage, a third consumed fuel at rates that made sustained operation impossible, and meanwhile, fighters sat idle. Pilots, eager to conduct reconnaissance missions and provide air cover for ground forces, still mopping up Japanese resistance on neighboring islands, could only wait and watch as mechanics struggled with equipment that should have worked but did not. McKenzie began considering alternatives. The challenge was straightforward: produce sufficient electrical current to turn over an aircraft engine starter motor. A typical fighter engine required approximately 24 volts at several hundred amperes for the starter to engage, substantial power, but not beyond the capacity of a properly configured generator. The military's portable ground power units produced this through large diesel engines driving industrial generators. But what if the diesel engine was replaced with something more reliable, more readily available, more resistant to the conditions that were destroying the specialized equipment? The Willys MB Jeep was everywhere in the Pacific, produced in enormous quantities over 360,000 during the war, and designed for extreme reliability. The Jeep had proven nearly indestructible. Its engine was simple, its electrical system robust, its maintenance requirements minimal. Mechanics joked that you could abuse a Jeep in ways that would destroy any other vehicle, and it would still run. What McKenzie recognized was that the Jeep's engine, while producing only 60 horsepower, was connected to a generator that provided electrical power for the vehicle's own systems. If that generator could be modified, upgraded, or replaced with a higher capacity unit, and if the engine's power could be harnessed efficiently, a Jeep might serve as an improvised ground power unit. The idea was technically sound, but practically daunting. It required fabricating a mounting system for a high-output generator, rewiring the Jeep's electrical system to handle higher amperages, and creating a voltage regulation system to prevent damage to aircraft electrical systems. It required doing all of this without a machine shop, without welding equipment beyond a single portable rig, and without technical manuals that addressed this specific modification. And it required convincing his commanding officer that the approach was worth attempting when conventional solutions, however inadequate, were at least officially approved. McKenzie presented the concept on the morning of November 17th to Captain Edward Morrison, the officer commanding aviation support operations on Macon. Morrison was a pragmatist, a former airline mechanic commissioned through Officer Candidate School, and he understood immediately both the potential and the risks. If the modification worked, it would solve the ground power crisis not just on Macon, but potentially across the Pacific, where every forward airbase faced similar challenges. If it failed, it would consume scarce time and resources that might be better spent continuing to coax functionality from the diesel generators. Morrison authorized McKenzie to proceed on one condition: the work had to happen at night, using personnel who could be spared from daytime operations, and had to produce a functioning prototype within 48 hours. After that, the logistics situation would force a decision: either the improvised solution worked, or the airfield would have to operate with degraded capability until replacement ground power units could be shipped from Hawaii. McKenzie assembled a team of 4 men, 2 aviation mechanics, 1 electrician's mate borrowed from a Navy shore party, and a Seabee welder who had experience fabricating structural components from scrap. They worked through the night of November 17th, beginning with a Jeep that had suffered minor battle damage, a shrapnel-punctured radiator, and damaged suspension that made it unsuitable for transport duties, but left the engine intact. The first challenge was mounting a generator of sufficient capacity. Military generators capable of producing the required amperage were in short supply, but McKenzie had identified an alternative: generators salvaged from damaged aircraft themselves. A P-40's electrical system included a generator capable of producing substantial current. If that generator could be driven by the Jeep's engine rather than the aircraft's engine, it might produce sufficient power. The fabrication was brutally improvised. Using angle irons scavenged from Japanese fortifications and sheet metal cut from destroyed equipment, the team built a mounting bracket that positioned the aircraft generator where it could be driven by a belt connected to the Jeep's engine. The belt itself was a problem. Aircraft generators operated at different speeds than Jeep engines, requiring specific pulley ratios to achieve correct generator RPM. The team calculated the ratios using pencil and paper, fabricated pulleys from steel stock using hand tools and the Seabee's welding rig, and assembled a system that looked, in McKenzie's later description, like something a farm mechanic would build to run a grain thresher. The electrical wiring was more complex. The generator's output had to be regulated to prevent voltage spikes that could damage aircraft systems. The electrician's mate, Petty Officer James Kowalski, rigged a voltage regulator salvaged from a damaged generator truck, integrating it into the Jeep's electrical system with wiring that bypassed the vehicle's original circuits entirely. The result was a hybrid system. The Jeep's engine provided mechanical power, the aircraft generator produced high amperage current, and the voltage regulator ensured stable output. On paper, it should work. In practice, it was an untested assembly of salvaged components that violated every principle of electrical engineering safety and military equipment standards. At 3:47 a.m. on November 18th, McKenzie started the modified Jeep's engine. It ran roughly. The additional load from the aircraft generator caused vibration that the engine's mounts were never designed to handle, but it ran. He engaged the generator and watched the voltmeter, a handheld unit connected to the output terminals. The needle climbed 12 volts, 18, 22, 24. It held steady at 24 volts, fluctuating slightly but remaining within acceptable range. The amperage, measured with a clamp meter around the output cables, read 320 amperes, more than sufficient to turn over a fighter engine's starter. The test was simple and definitive. At dawn, with Captain Morrison and a small group of mechanics and pilots watching, McKenzie drove the modified Jeep to where a P-40 sat with its cowling open, engine cold. He connected heavy-duty cables from the Jeep's output terminals to the aircraft's starter motor input. The pilot, a young lieutenant from Texas who had been grounded for 4 days by the ground power failures, climbed into the cockpit. McKenzie gave a thumbs up. The pilot engaged the starter. The sound, a rising whine as the starter motor spun, followed by the coughing bark of the Pratt & Whitney engine catching, was the most beautiful thing anyone on that airfield had heard in days. The engine fired, stumbled, caught fully, and settled into a steady roar. Blue exhaust smoke drifted across the coral runway. The modified Jeep, its own engine racing to maintain generator output, shuddered but held steady. McKenzie monitored the voltmeter and amperage throughout the startup sequence. Everything remained within tolerances. The system worked. Word of McKenzie's modification spread through the Pacific theater with the speed of desperation. Every forward airbase commander faced identical challenges: inadequate ground power equipment, limited repair facilities, aircraft sitting idle for lack of electrical power to start them. The improvised Jeep-based ground power unit solved all of these problems simultaneously. Jeeps were abundant, essentially indestructible, and familiar to every mechanic in the Pacific. Aircraft generators were available from damaged planes that would never fly again. The fabrication could be accomplished with basic tools and welding equipment that Seabee units possessed in quantity, and the resulting system, while inelegant, was more reliable under field conditions than the complex diesel generators it replaced. Within a week, McKenzie was ordered to document his modification in sufficient detail that other bases could replicate it. He produced a hand-drawn schematic, a parts list, and a set of assembly instructions that were distributed through 5th Air Force maintenance channels. By December 1943, modified Jeeps were providing ground power at bases across the Gilbert Islands, the Marshalls, and the Solomons. By early 1944, the modification had been refined through multiple iterations: improved mounting brackets, better voltage regulation systems, standardized parts that could be ordered through supply channels, and had become semi-official, acknowledged in technical bulletins if not formally approved in equipment manuals. The impact on operational tempo was immediate and measurable. Airfields that had struggled to launch a dozen sorties per day due to ground power limitations could now support full squadrons. Fighters could be scrambled on short notice, with pilots confident that reliable ground power would be available. Maintenance downtime decreased as mechanics no longer had to spend hours coaxing temperamental diesel generators to function. The modification was not glamorous, it did not increase aircraft speed, did not improve weapons, did not win dogfights. But it solved a logistics problem that had been throttling American air operations, and in doing so, it contributed to the relentless pressure that American forces brought to bear on Japanese positions throughout 1944. Japanese military records from this period reflect a growing sense of being overwhelmed, not by American tactical brilliance, but by American material abundance and adaptability. A captured Japanese intelligence report from mid-1944, analyzing American airfield operations, noted enemy demonstrates remarkable ability to establish functional airbases on islands with minimal infrastructure. Their maintenance personnel solve equipment problems with improvised solutions that our forces would require specialized factories to produce. This suggests industrial capacity and technical flexibility that we cannot match. This observation was accurate but incomplete. What the Japanese intelligence analysts perceived as industrial capacity was, in significant measure, the accumulated effect of thousands of individual improvisations by mechanics, engineers, and technicians who refused to accept that equipment failures were fate. McKenzie's Jeep modification was one such improvisation. There were hundreds of others, most undocumented, most forgotten: field-modified fuel pumps, improvised parts, fabricated from scrap, electrical systems rewired in ways that would horrify safety inspectors, but that kept aircraft flying and missions launching. The symbolic power of McKenzie's modification extended beyond its technical merit. The Jeep itself had become, by 1943, an icon of American military capability, unpretentious, reliable, ubiquitous. Every theater of the war had photographs of Jeeps, carrying generals to frontline meetings, evacuating wounded, towing artillery, serving as ambulances, reconnaissance vehicles, and supply trucks. The Jeep was democracy on wheels: simple, functional, accessible, effective. It did not inspire fear like a tank or awe like a bomber. It inspired confidence. It suggested that American industry could produce anything in any quantity, that no challenge was too complex to solve, that the vast productive capacity of the United States could be brought to bear on every problem from the largest strategic question to the smallest logistical detail. When McKenzie transformed a Jeep into a power generator, he was, perhaps unconsciously, demonstrating the essence of the American war effort. Nothing was sacred, everything was adaptable, and the mission determined what tools became. A vehicle designed for transportation became a power source. An aircraft generator designed to power radios and lights became a starter motor driver. Scrap metal from enemy fortifications became mounting brackets. The entire assemblage violated formal doctrine, but it worked, and in war, effectiveness trumps orthodoxy. For the young pilots who flew from the bases that McKenzie's modification supported, the sight of a Jeep positioned beside their aircraft, cables running from its jury-rigged generator to their fighters' starter terminals, became a symbol of confidence. It suggested that someone, somewhere in the logistics chain, was thinking creatively, was solving problems, was making sure they could fly. The smooth hum of a Jeep engine at idle, barely audible over the wind and surf, became the sound that preceded the roar of fighter engines starting, the sound of readiness, of capability maintained through ingenuity. This sound, humble, industrial, utterly unmilitary, was in many ways more representative of American strength than the thunder of bombers or the crack of naval guns. It was the sound of a society that built quarter-ton vehicles with such reliability that they could be repurposed into power generators without modification to the engine itself. It was the sound of decentralized problem-solving, of technical expertise distributed so widely that a mechanic on a coral atoll could design and build a system that solved theater-wide logistics failures. It was the sound of an economy so productive that when specialized equipment failed, there was enough surplus capacity to improvise alternatives from abundant general-purpose equipment. McKenzie remained on Macon Atoll through January 1944, overseeing the refinement of his modification and training other mechanics in its application. He was then transferred to a maintenance depot in Hawaii, where he worked to standardize the Jeep-based ground power system and integrate it into official supply and maintenance protocols. The Army Air Forces, initially resistant to formally adopting a field modification that violated equipment safety standards, eventually acknowledged reality. By mid-1944, requisition forms existed for generator, ground power, vehicle-mounted, improvised McKenzie type, the only piece of military equipment in the Pacific Theater known officially by an individual's name. McKenzie received a Bronze Star for his work, presented in a brief ceremony at Hickam Field, in March 1944. The citation noted his ingenuity and technical expertise in solving critical equipment shortages under combat conditions. He accepted the medal with characteristic modesty, insisting that any competent mechanic would have done the same. This was not entirely true. Many competent mechanics had encountered the same problem and had continued working with the inadequate diesel generators, because that was the approved equipment. McKenzie had looked at the problem differently, had recognized that the constraint was not mechanical possibility, but institutional thinking, and had acted accordingly. After the war, McKenzie returned to Oklahoma and reopened his repair shop. He gave few interviews about his military service, and seemed uncomfortable with the attention that occasionally came his way when military historians researched Pacific logistics. When asked about the Jeep modification, he typically deflected, noting that he had simply made something work that needed to work. This humility was characteristic of his generation and obscured the significance of what he had accomplished. He had not merely solved a local equipment problem, he had identified a systemic failure in military logistics, the reliance on specialized, complex equipment in environments where simplicity and reliability were paramount, and had demonstrated an alternative approach that proved more effective than the systems designed by engineers in peacetime offices. The modified Jeeps remained in service throughout the Pacific Campaign. Photographs from Iwo Jima, Okinawa, and the Philippines show them positioned beside fighters and bombers, their improvised generator assemblies clearly visible, cables snaking to aircraft parked on runways carved from volcanic ash or jungle. Some survived the war and were photographed in the occupation of Japan, still functioning, still providing power to aircraft at bases that had been Japanese strongholds months before. The last documented use of a McKenzie-type ground power unit was in 1946, at a base in the Philippines being decommissioned as American forces demobilized. After that, they disappeared, scrapped, abandoned, forgotten as the peacetime military returned to standardized equipment and formal procedures. The story of William McKenzie and his improvised ground power system is a story about the nature of military innovation during total war. The great technological achievements of World War II, radar, the atomic bomb, the proximity fuse, receive extensive historical attention because they were dramatic, because they involved scientists and vast research programs, because they represented revolutionary advances in human knowledge. But wars are won not only by revolutionary technologies, but by the accumulation of thousands of incremental improvements, field modifications, and practical solutions to immediate problems. Most of these innovations are never documented, never recognized, never remembered. Mackenzie's modification falls into this category. It was not revolutionary. It did not involve new science or radical engineering. It was simply the intelligent application of existing components to solve a problem that formal systems had failed to address. But its impact was disproportionate to its simplicity. By restoring operational capability to forward air bases throughout the Pacific, it enabled the high operational tempo that characterized American advances in 1944. Every fighter sortie launched with power from a modified Jeep, every reconnaissance mission flown, every air cover provided to amphibious forces, these accumulated into strategic advantage. The Japanese, observing this from the receiving end, struggled to comprehend the source of American adaptability. Japanese maintenance procedures were rigorous, their equipment often superior in quality, their mechanics highly trained, but Japanese military culture emphasized discipline, procedure, and respect for expertise. A Japanese mechanic who encountered failed ground power equipment would report the failure up the chain of command and wait for replacement units or expert repair personnel. The idea of modifying a vehicle to serve a completely different function, of violating equipment specifications to achieve mission requirements, of acting without formal approval because the situation demanded action, these were foreign concepts, incompatible with military culture that valued obedience over initiative. This cultural difference was not a matter of intelligence or courage. Japanese soldiers and mechanics were both intelligent and courageous. It was a matter of institutional philosophy, of whether military organizations valued adherence to procedure or achievement of objectives, whether they trusted junior personnel to exercise judgment or required approval from superiors, whether they viewed regulations as binding constraints or as guidelines to be followed when circumstances permitted. The American military, reflecting the democratic society that produced it, leaned toward the latter approach. This created inefficiencies, certainly wasted effort on failed experiments, inconsistent standards, occasional chaos. But it also created an environment where a sergeant on a coral atoll could redesign ground support equipment and have that redesign adopted theater-wide within weeks. There is a particular sound that veterans of the Pacific Campaign remember, a sound that was present at every airbase from Guadalcanal to Okinawa, but that civilians never heard, the idle hum of a Jeep engine, overlaid with the higher-pitched whine of a generator spinning under load, followed by the explosive cough and roar of a fighter engine starting. This sequence, humble mechanical hum giving way to thunderous power, captured the essential relationship between logistics and combat, between the unglamorous work of maintenance and the dramatic results of air operations. The Jeep's hum was the sound of problems being solved quietly, out of view by men whose names would never appear in newspapers, but whose work made everything else possible. It was the sound of American industrial capacity distilled to its essence, simple, reliable machines produced in enormous quantities and adapted creatively to meet needs their designers never anticipated. It was the sound of a mechanic's intuition proving more valuable than an engineer's specifications, of practical experience trumping theoretical knowledge, of democracy's faith in the individual's capacity to identify and solve problems without waiting for permission from authority. For the pilots who relied on Mackenzie's modification, the sound became a form of assurance. When they heard that Jeep engine humming beside their aircraft, when they saw the jury-rigged cables and improvised mounting brackets, they understood that someone had cared enough to make things work, to ignore regulations when necessary, to ensure that they could fly their missions. This was not merely technical support, It was a promise, made manifest in salvaged parts and welded steel, that the vast system behind them, the supply ships and maintenance depots, the factories and training bases, the entire industrial apparatus of American warfare, was focused on one objective: ensuring that they could fight effectively. Japanese pilots, flying from bases where equipment failures often grounded aircraft for days or weeks, where replacement parts might never arrive, where mechanics followed procedure but lacked authority to improvise, operated under different psychological conditions. They were brave, often fanatically so, but they fought knowing that their material disadvantage was growing worse with each month, that equipment losses could not be replaced, that the industrial system supporting them was strained beyond capacity. The sound they heard before missions was often silence: aircraft sitting idle, engines that could not start, missions cancelled for lack of functional equipment. By late 1944, as American forces closed on the Japanese home islands, the cumulative effect of logistical superiority had become overwhelming. Japanese industry, despite desperate efforts, could not produce aircraft, fuel, and spare parts in sufficient quantities to sustain combat operations. American industry, by contrast, produced such abundance that field commanders worried more about managing supplies than about shortages. This abundance was not merely a matter of factory output, it was also a matter of efficiency, of systems that worked, of equipment that could be maintained under field conditions, of logistics that moved supplies forward reliably and rapidly. McKenzie's Jeep modification was one small component of this larger system, but it exemplified the characteristics that made the system effective: adaptability, pragmatism, decentralization of problem-solving, and faith in the competence of individual soldiers and mechanics to identify solutions without constant supervision. These characteristics were not unique to logistics. They permeated American military operations at every level, from squad tactics that emphasized individual initiative to strategic planning that allowed theater commanders substantial autonomy, and they reflected fundamental values of American society: democratic governance, respect for individual capability, skepticism of rigid hierarchy, belief that problems existed to be solved rather than endured. The contrast with Japanese military culture could hardly have been starker. Japan fought the Pacific War with courage and determination, with tactical innovation and strategic vision. But Japan fought with an industrial base 1/10 the size of America's, with supply lines that stretched across an ocean they could no longer control, and with a military culture that struggled to adapt when circumstances deviated from plans. American advantages in resources and production are well documented. Less often acknowledged is the advantage of institutional flexibility, the capacity to recognize when systems were failing and to empower individuals to develop alternatives. William McKenzie died in 1978, at the age of 66, in the same Oklahoma town where he had been born and where he had operated his repair shop for 40 years. His obituary in the local newspaper mentioned his military service briefly, noting that he had served in the Pacific and received a Bronze Star. It made no mention of the ground power modification, of the dozens of bases where his innovation had enabled air operations, of the pilots who flew missions powered by equipment he designed. This anonymity was not unusual. Most of the men who sustained the American war effort, through technical expertise and practical problem-solving, returned to civilian life without recognition, without monuments, without their names entering history books. But the legacy of their work endures, not in memorials, but in the historical record of what American forces accomplished during the Pacific Campaign. The speed of advance, the operational tempo, the ability to project air power from captured islands almost immediately, these achievements rested on logistics and maintenance, on the unglamorous work of keeping equipment functional in hostile environments, on the accumulated effect of thousands of field modifications and improvised solutions. McKenzie's contribution was significant but not unique. It was representative of a broader culture of innovation that permeated American military operations, and that gave American forces advantages that raw industrial capacity alone could not provide. The Jeep, unpretentious, ubiquitous, adaptable, became the perfect symbol of this approach. In McKenzie's hands, it became a power generator. In other hands, it became an ambulance, a reconnaissance vehicle, a weapons platform, a command post, a communications hub. Its versatility was not a feature of its design, but a consequence of the mindset of the soldiers who used it. They saw not a vehicle with specific designated purposes, but a tool that could be adapted to whatever purpose the mission required. This perspective, that tools exist to serve objectives rather than objectives being constrained by available tools, was fundamentally democratic. It assumed that individuals closest to problems were best positioned to develop solutions, that authority should enable rather than constrain innovation, that regulations existed to facilitate mission success rather than to be followed for their own sake. There is a photograph, taken on Makin Atoll in late November 1943, that captures McKenzie and his team beside the first modified Jeep. The image is grainy, poorly exposed, typical of combat photography from the era. McKenzie stands at the left, one hand resting on the improvised generator mounting, his expression not proud or celebratory but simply satisfied, the look of a craftsman who has completed difficult work and knows it functions as intended. Behind him, the coral runway stretches toward the horizon, and a P-40 sits with its propeller spinning, engine running, powered by the very system McKenzie has just created. The photograph exists in military archives, uncatalogued, unknown except to researchers who study Pacific logistics in detail. But the image captures something essential about the American war effort that formal histories often miss. There are no generals in the photograph, no flags or ceremonies, no dramatic action. There is only a mechanic and his improvised solution to a problem, and an aircraft running because that solution worked. This was how wars were won, not through grand strategy alone, though strategy mattered, not through industrial might alone, though production capacity was crucial, but through the accumulated efforts of ordinary men who refused to accept failure, who looked at broken systems and saw possibilities for repair and adaptation, who trusted their own expertise enough to act without waiting for permission. The sound of that P-40's engine, audible even in the silent photograph, was the sound of McKenzie's stubborn refusal to accept that the ground power crisis was unsolvable. It was the sound of American adaptability made manifest in welded steel and salvage generators. It was the sound of freedom asserting itself through practical problem-solving and democratic faith in individual capability. And it was the sound that echoed across the Pacific throughout 1944 and 1945, at every forward airbase where modified jeeps hummed beside fighters preparing for missions, where mechanics improvised solutions to problems that formal systems could not address, where the unglamorous work of logistics made possible the dramatic achievements of combat operations. In the decades since World War II, military technology has advanced beyond anything McKenzie could have imagined. Modern aircraft carry their own auxiliary power units, eliminating the need for external ground power in most circumstances. Electrical systems are sophisticated, computerized, designed with redundancies that make field modifications unnecessary. The improvised, jury-rigged solutions that characterized Pacific airbases have been replaced by standardized equipment and formal procedures. This is, in most respects, an improvement. Modern military forces operate more efficiently, more safely, with fewer equipment failures and better logistics. But something has been lost as well. The culture of improvisation, the expectation that soldiers at every level would exercise initiative and solve problems creatively, the faith that a mechanic on a remote airbase might have insights that engineers at headquarters lacked. Modern militaries, like modern societies, have grown more specialized, more bureaucratic, more dependent on complex systems that function brilliantly when circumstances match expectations, but that struggle to adapt when confronted with unanticipated challenges. The lessons of the Pacific Campaign, that adaptability matters as much as technology, that decentralized problem-solving produces better results than rigid adherence to procedure, that individuals empowered to act can achieve what formal systems cannot, remain relevant, but are often forgotten in peacetime. McKenzie's story is worth remembering, not as nostalgia for simpler times, but as a reminder of what ordinary people can accomplish when circumstances demand innovation and institutions permit initiative. He was not extraordinary by birth or training. He was a small-town mechanic who understood engines and who refused to accept that equipment failures should ground aircraft and compromise missions. He looked at the tools available, jeeps, salvage generators, scrap metal, and saw not limitations but possibilities. He acted without formal approval, because the situation required action, and his work, multiplied across dozens of airbases and hundreds of aircraft, contributed meaningfully to American victory in the Pacific. The Jeep's hum, humble and mechanical, was the sound of that contribution. It was the sound of problems being solved, not through superior resources alone, but through superior adaptability. It was the sound of democracy at war, unpretentious, practical, effective, and it was the sound that carried American forces across the Pacific, from coral atoll to volcanic island, to the shores of Japan itself, powered not only by industrial might, but by the stubborn creativity of men who refused to accept that any problem was truly insoluble. In the end, wars are contests not merely of weapons but of systems of production, logistics, maintenance, and adaptation. The side that can sustain operations, that can solve problems faster than they emerge, that can adapt equipment to changing circumstances, that can empower individuals to innovate within mission constraints, that side possesses advantages that raw firepower cannot overcome. In the Pacific War, America possessed these advantages not because Americans were inherently superior, but because American culture and institutions created environments where initiative was rewarded, where practical expertise was respected, where a mechanic could redesign ground support equipment and have that redesign adopted theater-wide because it worked. William McKenzie, working through the night on a coral airstrip, 8,000 miles from home, exemplified this culture. His hands were greasy, his tools improvised, his methods unorthodox, but his engines started, his aircraft flew, his missions launched. And in the calculus of war, where success is measured in objectives achieved rather than procedures followed, that was everything that mattered. The sound of a Jeep engine idling beside a fighter aircraft, generator spinning, power flowing, that sound has not been heard in combat for 80 years. But its echo remains, a reminder that innovation often comes not from laboratories or headquarters, but from the front lines, from the hands of those who confront problems directly and refuse to accept that solutions do not exist. That stubbornness, that pragmatic creativity, that democratic faith in individual capability, these were weapons as powerful as any bomb or bullet, and they were wielded by men whose names history has largely forgotten, but whose work made victory possible.